Hello guys, welcome to Math City with Miss G. In this video, we are going to talk about transversal line proof. So on the screen, we are given with two pairs of parallel lines. We'll start with A and B. So I'm going to emphasize the lines. We have A and B, which are parallel to each other. And I am going to use the arrows to emphasize that these two lines are parallel. The second set of lines that are parallel are C and D. So this information will help us to prove that angle 1 is congruent to angle 13. So looking at 1 and 13, yes, they do look like they're congruent. Congruent meaning equal in measure. But we are to prove how are they equal in measure. So there are multiple ways to do this. So one way is to introduce 1 and 9. So 9 is right here and 9 corresponds to 1. And then from 1 to 13, we could use corresponding angles to connect 1 with 13. We could also use another strategy by using 1 and 12, because 1 and 12 are alternate exterior angles. And then from 12, we could connect that 1 using 12 with 13, because 12 and 13 are alternate interior angles. So that is one way to prove it. So let's go ahead and write it down so you will understand what I was just talking about. So we're going to begin with the first statement. So A is parallel to B and C is parallel to D, and the reason is given. Now, if there are two given, we could split the two given and put them in different statements, but you could also put it in one statement, just like what we're doing right now. So we're going to start with angle 1. So angle 1, I would like to use 12. Angle 12 is congruent to angle 12. So 1 and 12, angle 1 and angle 12 are alternate exterior angles. They are opposite sides of the angle of the line A, and they are outside of line C and D, so they are called alternate exterior angles. Now, from that information, we can make connection from 12 to 13. 12 and 13 are angles that are considered alternate. They're opposite sides of line D. So they're alternate, but they're inside of lines A and B. So angle 12 is congruent to angle 13. Congruent meaning equal in measure, and so we call this alternate interior, because they're inside the lines A and B. So alternate interior angles. Now, using the information that we have at this time, we can then go back and take a look at statements 2 and 3. So notice that there is a common angle, and that is angle 12. Since angle 12 is common to both, then we can say that angle 1 is congruent to angle 13. So that is going to be our number 4 statement. So angle 1 is congruent to angle 13, which uses the concept of transitive property. So notice that our last statement in the statement should be exactly the same as what we are supposed to be proving. Okay, let us try another problem. Number 2. So in this problem, we are given with line A, which is parallel to B. And using this information, we are to show that the measure of angles 9 plus the measure of angle 14 is equal to 180 degrees. Now, again, let's recall the angle pairs of parallel lines cut by a transversal. So none of the angle pairs is going to match with these two sets of angle 9 and 14. So we have to show two-column proof in order for us to show that these two angles are indeed equal to 180 degrees. So let's begin by writing the given. So number 1, A is parallel to B, and that is given. Now, since we are to show something about angle 9, so I would like to begin with angle 9 and pair that angle 9 with another angle where when added together it is equal to 180 degrees. And then with that information we can make connections from that angle to angle 14. So I'm looking at angle 9 and 11. So 9 and 11. So these two angles make up a straight line. So these two angles when added together is equal to 180 degrees. That means they're linear pair. So number 2 statement can be measure of angle 9 plus measure of angle 11 is equal to 180 degrees. And these two angles make up or is called linear pair. And if you have noticed in the illustration, we have here two angles that are congruent or equal in measure. I'm looking at 11 and 14. They are alternate interior angles. So our number 3 statement can be measure of angle 11 is equal to measure of angle 14. And again, they're opposite sides of line D, so that's alternate, and they're inside lines A and B, so that's alternate interior angles. Now looking at the statement that we have so far in statements 2 and 3, we are able to come up with something. And what is that something? Notice that 11 is equal to measure of angle 14. So instead of writing measure of 11, we can substitute that information with measure of angle 14. So measure of angle 9 from statement number 2 plus measure of angle 14 is equal to 180 degrees. And this is using the concept of substitution property. All right, let us try one more problem. Number 3. So in this problem, we are given with two pairs of parallel lines. So L and M are parallel to each other. We're also given that the other set of lines are parallel. P and Q are parallel to each other as well. So we are to show that angle 2 is congruent to angle 3. Yes, they are congruent. There's something wrong here. Oh, there's a mistake here. I was right. Okay. Apologies about this, but this is supposed to be 5. Okay. So we are to prove that 2 is congruent to angle 5. Okay. Yes, they look like congruent, and yes, they look like they're inside, so interior. But again, going back to the angle pairs of parallel lines cut by a transversal, none of the illustration supports this example. And so we need to show two-column proof in order to show that these two angles are indeed congruent. So we're going to start with the given. P P is parallel to Q, and that's given. This time I would like to split the two, so L is parallel to M, and again, it is okay to put them in one line or one statement. Okay, so from here, we could start with angle 2 because that's where we're heading. So number 3, angle 2 is congruent to. Okay, so we're gonna make connections, and 2 is congruent to, as you can see on the screen, 2 is congruent to angle 3. Okay, so they are opposite sides of line L. So that is 2 is congruent to angle 3, and they're called alternate. And they're inside lines P and Q. So alternate interior angles. Now, from that information, we can then introduce that angle 3 is congruent to angle 5. Angle 3 is right here and angle 5 is right here. They are called corresponding angles. So that would make our number 4 statement. And again, we mentioned that they're corresponding, so that is our reason, corresponding angles. Now, looking at the statement that we have in number 3 and 4, there is a common angle, and that is angle 3. So then, therefore, we can say in number 5 that angle 2 is congruent. Oh, hold on. I made a mistake right here of writing angle 4. That is supposed to be 5. I'm sorry, guys. This is angle 5. So, let me go back. Angle 2 is congruent to angle 5, and this is using the concept of transitive property. And looking back, I made 2 mistakes here and apologize for that. But there we go. Our last statement match with the problem that we are to prove that they're indeed congruent. I hope you find value in this video. Thank you so much for watching. Have a good day. Bye.